I talked about relationships in the earlier section on features of a relational database, but it's time to get more specific. You're organizing your database into individual tables, and many of these tables will need to know about each other. Now, if you've started by sketching out a rough entity relationship diagram, you begin by just attempting to show that some kind of relationship exists between your entities. But to get closer to actually building this in a database, we need to say what these relationships are. And while it is common in an ER diagram to use a phrase or a verb to describe it, like contains or refers to or belongs to, that's for your benefit. The database can't describe it that way. Now, there are only 3 kinds of relationship, of cardinality between tables in a relational database, and one of them dwarfs the others. There's one-to-one, one-to-many, and many-to-many. And okay, some people might add a fourth of none at all. But the time to start defining these is yet another example of how you can keep to a process and order when designing databases. First, you sketch out your entities, which will become your tables. Then you're going to define the data, the attribute for those entities, which will become columns in your tables. Because only then can you say which columns will be the primary keys, or if you need to generate primary keys. And you can't properly define your relationship until these primary keys are specified. Now, I'm not trying to pretend that it's a purely linear process. Not all your tables will become obvious in the first couple of steps. When you go through the process of normalization, which we'll get to in the next section, you'll probably end up with a few new tables. So we will revisit everything we've started to define, but we can still work through a process. Now, the benefit of specifying our relationships formally in the database, rather than just informally putting things together in an application, is that the database management system itself will take care of keeping those relationships valid and meaningful. And you can then use those relationships to answer all sorts of questions. Everything from the basic idea of how many orders has a particular customer had, and how many products were in an order, or say in a game system, what weapons belong to a particular player, how many quests has one player completed compared to another. And all the data is stored in these separate tables, but it becomes easy to jump from one to another by following the relationships. So next, we'll get into the most common, the one-to-many.